Unit rates and unit pricing. Today, you're going to figure out how to solve for both of those. It says a unit rate should be filled in. Sorry. A unit rate is a ratio that compares two quantities. Sorry, a rate is a ratio that compares two quantities measured in different units. A unit rate is a rate whose denominator is equal to 1. Okay? To change a rate to a unit rate, you divide both the numerator and the denominator by the denominator. Okay? The key operation for today is divide. Okay? So here's our question. It says, a Ferris wheel revolves 35 times in 105 minutes. How many minutes does one revolution take? So the first thing you're going to do is you're going to set up your words that you're comparing. You're comparing minutes to revolutions. You're given 105 minutes and 35 revolutions. We do not know how many minutes it takes for one revolution. Okay, so we have them set into the boxes. Now we're going to cross multiply. 35 times x equals 35x equals 105 times 1 is 105. Okay, this is your equation. This is what's going to help you solve for how many minutes it takes. This is something I always need to see on your work. Okay, so to figure out how many minutes it takes for one revolution, we're going to divide both sides by 35. This is just like when we solved equations. The 35's cancel, so you're left with x equals 105 divided by 35, so you're just going to divide it out over here. 35 can't go into 1, 35 can't go into 10, but 35 goes into 105 3 times. So for this unit rate, you have 3, make sure you label it minutes. So the answer for this problem is 3 minutes in one revolution, or it takes 3 minutes to complete one revolution for this Ferris wheel. Next one. It says Sue walks 6 yards and passes 24 security lights set along the sidewalk. How many security lights does she pass in 1 yard? So again, we're going to set up our word problems. Yards to lights. The 6 is attached to the yard, so we're going to put 6 and then 24 security lights. The 1 is attached to yard here, so it's going to go next to the yard in the box or in the chart. And we do not know how many lights that is, so that's our variable or our x. Again, we're going to cross multiply. 24 times 1 is 24 equals 6 times x is 6x. Remember, the number always comes before the variable. Okay, so now to solve for how many lights you get in 1 yard, you're going to divide both sides by 6. The 6's cancel, so you get x equals 24 divided by 6 is 4, and make sure you label lights. You always need to have the equation after you cross multiply and the label in your answer. Okay, so let's try another one. It says a dog walks 696 steps in 12 minutes. How many steps does the dog take in 1 minute? We're comparing steps to minutes. 696 is attached to the steps. 12 minutes is attached, or 12 is attached to the minutes. 1 is attached to the minute here, so the 1 goes next to the minutes. We do not know how many steps. That's what we're looking for, so we have our variable. Now we're going to cross multiply. 12 times x is 12x equals 696 times 1 is 696. Again, we want to figure out how many steps go in 1 minute, so we're going to divide 12 on both sides. 12's cancel. X equals, you have to divide 696 divided by 12. Okay, 12 cannot go into 6. 12 goes into 69 5 times, and you get 60. 69 minus 60 is 9. Bring down 6. 12 goes into 96 8 times. So the answer for this is 58 steps. Again, remember to always label for unit rates. Try this next one on your own. Pause the video and then check it. Okay, so for this one, you have 12 smoothies and 30 cups of ice. So you have smoothies to ice, and 12 goes with smoothies, 30 goes with ice. It says how many cups of ice does he need for one smoothie? So 1 goes with smoothies, and the variable is x. Now we're going to cross multiply. 30 times 1 is 30 equals 12 times x is 12x. Divide both sides by 12. 12's cancel. X equals 30 divided by 12. Divide it out. 12 goes into 30 2 times. Sorry. Yes, 2 times. You get 24. 30 minus 24 is 6. Now, since it does not give you the specific form that you need it in, you can have it in either fractions or decimals. If you have it in a fraction, the 6 becomes the numerator and the 12 is the denominator. But you have to simplify. So that is 2 and 1/2. If you did it with a decimal, you add a decimal and bring it straight up, add a 0 and bring it down. 12 goes into 60 5 times. So you could have 2 1/2 or 2 5/10 cups of ice. So you could put cups of ice. Okay. Either one of these will work since it did not say that you have to have a specific form. Okay. Now, it says an average rate of speed, average rate of speed is the ratio of distance traveled to time. The ratio is a rate because the units in the numerator and the denominator are different. To find the average rate of speed, it's going to be the same process that we were just doing for unit rate. You compare the two words. In this one, it says Danielle is cycling 68 miles as a fundraising commitment. She wants to complete her ride in 4 hours. What should be her average speed in miles per hour? So we're comparing miles to hours. So you're going to compare your words, then attach the numbers to what it was next to in the problem. Now this is the only thing that changes. It says what should be her average speed in miles per hour. Imagine that there's a 1 right there. So per 1 hour. So the 1 is attached to hour, which goes here. And we're looking for how many miles, which is the variable. And it's going to be the same thing. We're going to cross multiply. 4 times x is 4x equals 68 times 1 is 68. Going to divide both sides by 4. And the 4's cancel. So we're left with x equals 68 divided by 4 is, let's do it out over here, 4, 1, 17 miles per hour. You can put MPH, that is the abbreviation for miles per hour. Let's do another one. It says Rhett is a pilot and needs to fly 1,191 miles to the next city. He wants to complete his flight in 3 hours. What should be his average speed in miles per hour? You can pause the video and work it out. Okay, so you should have set up miles to hours, 1,191 miles to 3 hours. We do not know how many miles it takes in 1 hour. We're going to cross multiply. So our equation that we get when we cross multiply is 3x equals 1,191. Divide both sides by 3. 3's cancel. So x equals 1,191 is 397 miles per hour. Remember to always label. That was it for unit rates. For unit pricing, it says a unit price is the price of 1 unit of an item. The unit depends on how the item is sold. So remember that you're always going to divide, there's our wonderful operation for this lesson, the money by the unit. So the money goes on top, the unit goes on bottom. The money goes inside the house, the unit stays on the outside. So this says a 12-ounce sports drink costs 99 cents. And a 16-ounce sports drink costs $1.19. Which size is the better buy? So the first thing we want to do is to figure out how much 1 ounce for each drink costs. So we are going to divide 99 cents divided by 12 and $1.19 divided by 16. Bring your decimal straight up over here. 12 cannot go into 9, so that's a 0. 12 goes into 99 8 times. 8 times 12 is 96. Subtract, you get 3. We know that money in America is to the hundredths place. However, we're going to solve to the thousandths because we have to round to the hundredths place. And we know we always look to the right. So we're going to add a 0 and bring it down. 12 goes into 30 2 times, which is 24. Now we can stop, even though it has not finished, because we are rounding to the hundredths place. The 8 is in the hundredths place. It looks to the 2. The 2 tells the 8 to stay the same. So for 1 ounce in the 12-ounce sports drink, you get 8 cents. For the 16-ounce sports drink, we're going to bring our decimal straight up. 16 cannot go into 1. 16 cannot go into 11. 16 goes into $1.19 7 times, and you get 112. Just like before, we're going to solve to the thousandths place because the 7 has to be rounded. So we have 7, bring down the 0. 16 goes into 74 times, and you get 64. Okay, but we're going to stop there. The 7 is in the hundredths place. It looks to the 4. The 4 tells the 7 to stay the same. So it is 7 cents. The better buy for this problem, we want to spend the least amount of money. So the better buy here is 7 cents. Excuse me. So you're going to divide always for the money. The money goes in, and whichever one is cheaper is going to be the better buy. Remember, for unit rates and unit pricing, the operation is division.